So you will find the MCQs in this pop quiz. This was pop quiz 3 related to the MCQs of the topics which we have completed. Any doubt in question 1? Feel free to ask your doubts if you have question 1. Any doubt in question 1? Question 2, 3, any doubt? Question 2 or question 3, any doubt? Question 3? Okay. So in this question, a bullet is fired horizontally with a speed v. So we have a bullet is fired with a speed v from a rifle. For a short time after leaving the rifle, only the force acting the motion is gravity, like only force affecting its motion is a gravity, and the expression of a free fall is g. Which expression gives the value for horizontal ratio between the horizontal distance travel and the vertical distance travel? So example, the horizontal distance travel will be the range and the vertical distance travel will be the height. So we want the ratio between the horizontal distance travel and the vertical distance travel. The horizontal distance depends on the horizontal component of the velocity and total time for the journey is t. So because there is no acceleration in the horizontal motion, no acceleration. So we have speed is equals to distance over time. So distance will be speed multiplied by time. The speed is v and the time is t. So the horizontal distance is v into t. Or you can also say the range as we are representing the horizontal distance by r range. So range is v multiplied by t. What about the vertical? Whenever object, as they mentioned, it is launched horizontally, a bullet is fired horizontally. So vertical velocity is 0, the starting velocity. The time it took t for this vertical distance. And what about the acceleration? Acceleration is due to gravity, which will be 9.8. So we can use the equation of the motion. We can use this equation. S is equals to ut plus half at square. The initial velocity is 0. So if initial velocity is 0, this factor will be 0. So it will be 1 by 2. Acceleration is due to gravity g and then t square. And the vertical distance, we said that is height. Why not vertical velocity? Just g. No, g is not the vertical velocity because the vertical component of the velocity in a projectile motion, when a projectile is dropped from certain height, at the maximum height it is 0. Means that if it is launched horizontally, and the vertical velocity will increase. And every time it increases by 9.8 or acceleration is due to gravity. So vertical velocity is not constant. Acceleration is constant or the increase in the velocity is constant. So the vertical height is h here. So h is equals to half gt square. Now what we have to do, we just have to simplify because we need the ratio between the horizontal and the vertical distances. So horizontal distance is r and the vertical distance is h. The horizontal distance is v multiplied by t and the vertical distance is half gt square. Now we simplify this equation. This t will cancel with the square and this 2 is, it's a denominator of a denominator, so it will move there in numerator. So this will become 2v divided by gt. So the ratio between the horizontal and the vertical distances is equals to 2v divided by gt. Is it clear? So whenever a projectile is launched, the horizontal velocity will be this, or the horizontal distance is speed multiplied by time. But for the vertical, we always use the equations of the motion. Question 4, 5, any doubt? Question 4 or 5? Question 6, any doubt? Question 4, 5, okay. In question 4, the particles moves in a manner as shown by the velocity time graph. The displacement of the particle has been measured so that it is at 0 at time is equals to 0. And point Q refers to the point on its motion. Which row in the table is correct? First, you can discuss about the acceleration whenever, because its velocity time graph is there. So whenever we have a velocity time graph, what the slope represent? The slope represent the acceleration of an object. So at this point, because it's a velocity time graph, so it's a curve. So when I draw a tangent at this point, it will be a horizontal line. And what is the gradient or the slope of a horizontal line? So the gradient or the slope of horizontal line is 0. So it means the acceleration should be 0. So first thing, either C can be an answer or D can be an answer. The second part is a maximum displacement. At which time interval it has a maximum displacement. So example, object is here, the starting point when t is equals to 0. The object speed is increasing. So the speed or velocity increase, and then the object velocity is decreasing. Then the object velocity is decreasing. Then what happened? The velocity has changed the direction. As you can see, the negative axis is used. So if we use the negative axis, what this indicate? This indicate that the object is moving in opposite direction, because velocity is a vector quantity. When we were using the positive axis and now we are starting to use a negative axis, what it shows? It shows the object has changed the direction. So the question is, at which position it has a maximum displacement? So which position it will have a maximum displacement? As the object move, first speed was increasing till the time like 2.5. So till 2.5, when the time is 2.5, the speed was increasing, object was moving towards right, example. Then the speed is decreasing, but the object does not change the direction till time is equals to 5 seconds, the object was still moving towards right. And then at 5 seconds, the speed of object is 0. And then what happened? The object changes the direction and now moving towards the mean position. And when it is moving towards the mean position, so speed is increasing, but a negative sign means it is moving towards the mean position, and then the speed is decreasing. This speed is decreasing, and a negative sign also shows that it is moving in opposite direction. So the question is the time for which the maximum displacement. So at which time? So at t is equals to 0, the object, like here, at t is equals to 7.5, and then t is equals to 10. So when t is equals to 10, what does it mean? It means the object has returned to the original position. So we will have to determine the time for a maximum displacement. Maximum displacement means like it is far from the. So time for the maximum displacement, one is at 5, another one is at 15. So D should be the right answer. Is it clear, this one? Any doubt in question 4? Any doubt in this? We want to determine the time for a table which is having a maximum displacement. So displacement is area under the graph. Okay. For a velocity time graph, if you have a velocity time graph, if you need a displacement, it is area under the graph. When I take the displacement, like example 2.5, so what will be the area under the graph? This will be the area under the graph. But when I take the displacement for 5, so what will be the area, the total area under the graph? So this will be the total area under the graph from 0 to 5. So which is having a maximum area under the graph at 2.5 or 5. So at 5, it is having a maximum. But why not 10? Why 10 is not acceptable? Because what actually happened, if we take the area from 5 to 10, so this area was representing R and this was representing S. So if I need the displacement here, it will be R minus S, and area of R and area of S is same. So means I will get a zero displacement. So area under the graph will give us the displacement of an object. Question 5. A tennis ball falls freely in air from the top of the building. Which graph represents the variation of a distance fallen? It is in air. So when we drop something, first what will happen, and this is a distance time graph. Okay. The distance time graph, the slope represents the speed. First, what will happen to the speed of a falling object? The speed of the falling object will increase. And then what will happen? For a falling object, the speed will become constant. When the speed becomes constant, as the weight of an object balances with the air resistance or the drag, there is no resultant force. Object will move at a constant speed. So first, the speed should increase, means the slope should increase. And then what should happen? Then what should happen? The speed is decreasing. Like speed is constant, so the slope should be constant. So for which graph we have the first part, increasing speed? Means the slope is increasing. Why constant? Because when objects are falling in air, as we did, the falling objects initially they will accelerate and the acceleration will decrease, but the speed will increase. And eventually what will happen? The weight of an object balances with the air resistance. So when the weight balances with the air resistance, there is no resultant force act on the object. So acceleration of an object should be 0 and it will fall at a constant speed. So first part, the speed should increase. The second part, speed should be constant. So when we check, for A, the speed is increasing the first part. For C, the speed is increasing as well. Why D is wrong? Because the slope is decreasing, it means the speed is decreasing. Why B is wrong? Because the slope is decreasing, it means the speed is also decreasing. So either A can be an answer or D can be an answer. Then the second part, the air resistance balanced with the weight, so it will move at a constant speed. So constant speed, how we represent a constant speed? We represent by a straight line. So when air resistance balanced with the weight, the speed will be constant or it does not change. It will reach a terminal velocity. That's why option A is the right answer. No, the speed will increase for falling objects. The speed will increase and then the speed will be constant. The speed will never decrease for falling objects unless if there is a parachute or if there is any other source which can increase the air resistance a lot, that will only decrease the speed. Otherwise, for falling objects in air, initially the speed will increase, then the speed will be constant. So why C is wrong? Because the C does not have a constant slope. C continuously the slope is increasing. That's why C is not acceptable. C shows that the object is falling and it's mentioned in air. So it means that air will affect the motion. So what is C is representing? C is representing that object speed is continuously increasing when it is falling through the air. But practically what happened when object is dropped, the speed first increase and then the speed will become constant. So what C is showing, and when the line is vertical, what is the slope of this vertical line? In maths, you have studied the slope of the vertical line is infinity. What it shows, it means the speed of an object will become infinite. If the vertical line is there parallel to y-axis, it means the object is having an infinite speed, which is not true for the falling object. Is it clear now? Question 6, a small glider moves along a friction-free. So there is no friction to oppose the motion. At each end, the air track that are perfectly elastic buffer. What is the meaning of perfectly elastic buffer? It means the same amount of energy is transferred back to the glider. So if the glider is moving, say, with a speed of 10, velocity of 10 meter per second, with this elastic buffer, when it bounces back, it will also bounce back with the same speed. There's no loss of energy and there's no friction. So the speed won't change. The only thing what will happen, the velocity will change because the direction has changed. So one is a positive velocity, other will be negative velocity. So when we sketch a graph for a velocity time, so first it is example having a plus 10 velocity. Then when it hits the glider elastic buffer, it will have a negative 10 velocity. Then again, when it hits the other glider and bounce back, it will have a positive 10 velocity. So this will be the shape of the graph for a perfect elastic motion in which the object does not change the speed. So what this one is showing, it shows that every time, what this shows when every time the object is changing the direction, it is changing the speed as well. Like first it was moving at 10 meter per second, but when it bounces back, it might bounce back with 8 meter per second. But it is not correct according to the information given in the question. It's a perfectly elastic buffer, means there is no loss of energy. This also shows that there is a loss of energy. Why C is wrong, even though C shows that the equal amount of speed, so 10 meter per second and minus 10 meter per second. But why C is not correct? Because it shows that it takes different time to move from one glider to another, which is wrong because if the speed is not changing, if the glider was taking like say 5 seconds to move from left to right, it will also take 5 seconds to move from right to left. So the time interval will be same as well. So we are left with option D as a correct answer. Is it clear? Question 5, question 7, 8 or 9. Any doubt? Question 7, okay. In question 7, remember one thing, acceleration is directly, according to Newton's second law, acceleration is directly proportional to the resultant force and the direction of the acceleration is always same as the direction of force, irrespective of what happened to the object. For example, if there was an object, it is moving at a speed of 10 meter per second and changes the speed to 20 meters per second. So what is the direction of the acceleration? Towards right, like it is changing the speed towards right. So what is the direction of the force? The direction of the force is also towards right. Same thing, if an object initially moving at a speed of 10 meters per second and it slowed down to 5 meters per second. So what is the direction of acceleration? Opposite, because it is deceleration. So what should be the direction of the resultant force? The direction of the resultant force should also be opposite. And if an object is moving in a circular path, if object is in a circular track, the force is, if this is the direction of the motion, the direction of the force is always toward the center. So what is the direction of the acceleration? That's also towards the center. So the two quantities which always remain in the same direction whenever object experience a resultant force is the acceleration and the force only. They're always, irrespective of kind of motion. It can be a simple harmonic motion. It can be a circular motion. It can be a rectilinear or a translatory or a straight line motion. All the cases, the direction of the acceleration is proportional to or same as the direction of force. Why option A is not correct? Look, first, the object was moving towards right, changes the speed from 10 to 20. So acceleration is same as velocity. But when the object is decelerating, the direction of the acceleration is opposite to the direction of the velocity, or we have a negative acceleration, which we also call. So it means in this case, when object decelerate, the velocity and acceleration does not have the same directions. The two physical quantities which are always having the same direction are the acceleration and the force, the resultant force. Is it clear? Question 7. So here the velocity is towards right, but acceleration also towards right. But if an object slow down, the velocity is towards right, but the acceleration is in opposite direction of the motion. So they are not in the same direction. Question 10, 11, any doubts? Question 10 or 11? Any question or doubt on 10, 11? 10, okay. Question 10. Look, the diagram shows a particle traveling at a speed v, about to collide with a stationary particle q with the same mass. So they have the same masses m and m. Which statement describes the motion of the particle, motion of p and q immediately after collision? First thing, there must be a conservation of the momentum. And because it is a perfectly elastic collision, what does it mean? There should be a conservation of kinetic energy as well. So we can say the momentum before the total momentum before must be equals to momentum after. And another condition, the kinetic energy before must be equals to the kinetic energy after. Why we specifically mention kinetic energy? As in the question it is mentioned that it is a perfect elastic collision. The perfect elastic collision, the kinetic energies are also same. So when we apply the principle of the momentum for the first option, what is the momentum before collision? This object has a mass m, velocity v, and this was not moving before the collision. It was stationary. So what is the total momentum before? The total momentum before is mv, all the cases. So the total momentum after should also be mv. So when we apply the rule here, that p rebound with the speed of minus v and q acquires the speed of v, half v, sorry. So what does it mean? It means, like example, mass m is there, p moves with the speed of v by 2, and m moves with the speed of v by 2. But rebound means like changes the direction. So one of the speed is positive, the other will be negative. So what is the momentum after? So it will be minus mv over 2. Why? Because momentum is a product of mass and velocity. So mass is m and the velocity is minus v by 2 because it has changed the direction. Plus, what is the momentum here? It will be mv by 2. Mass is m and the velocity is v by 2. So when we simplify this, this will cancel. So A can be an answer if the initial momentum is 0. The final should also be 0, but the final momentum for option A is coming out 0, but we want the final momentum to be mv. That's why A is not the right answer. Because when we use this equation for conservation of the momentum, in case of A, the total momentum after is 0. But according to the question, if the momentum before is mv, the momentum after should also be mv. That's why A is not the right answer. Now, if we check option B, if you check the second option, P rebound with a velocity v and the Q remain stationary. So P is there, it rebound with a velocity v and Q is stationary. So what is the momentum? Because it rebounds, so means the velocity becomes negative and the mass is m. So what is the momentum here? Minus mv and this is 0. So what is the total momentum after? The total momentum after is minus mv. But here we want mv. So with option B, the total momentum after will be minus mv, but we want m into v. So it is not same as the initial momentum. That's why option B is also incorrect. When we check option C, when we check option C, P and Q both travel in the same direction as V by 2. So P and P and Q, P is moving at a speed of V by 2. Q is also moving at a speed of V by 2. The mass is m, the mass is n. So the momentum will be mv by 2 and the momentum here is also mv by 2. So mv by 2 plus mv by 2, this is equals to mv. So that is, the momentum is conserved. That's the first condition which is fulfilled, that the momentum is being conserved. But the second condition, because it's an elastic collision, the kinetic energy should also be conserved. So the momentum is conserved, the momentum is mv. But what about the kinetic energy? The kinetic energy before should be equals to kinetic energy after. So how to work out the kinetic energy before? Kinetic energy is half mv square. So this object was having a mass m, velocity v, so the kinetic energy will be half mv square. And this object was stationary, so the kinetic energy is 0. So the kinetic energy before is half mv square. So before is half mv square, final should also be half mv square. Now, in option C, they mentioned both travel with a speed of v by 2. So m is there and the speed is v by 2. And this m is there, the speed is also v by 2. Means they stick together what they make here. So the kinetic energy will be half 1 by 2 m v square. So what is v? So it will be v by 2 square plus the kinetic energy of the second object half m, the velocity is v by 2 square. So when we simplify this, I will solve here. So this will become half m v square by 4 plus half m v square by 4. So this will be mv square by 8 plus mv square by 8. So when you add mv square by 8 with mv square by 8, so this will give you mv square by 4. So the total kinetic energy according to option C after the collision, the total kinetic energy is mv square by 4. But we want the total kinetic energies mv square by 2 or half mv square. So momentum was conserved, but the kinetic energy is not conserved in option C. And what about option D? For option D, when the objects collide and P comes standstill and the Q acquires a speed V. So Q is moving at a speed of V and the P is a standstill. Means P is not moving. So the momentum will be conserved because of mass into velocity. This is zero, so the momentum is conserved, which is mv. What about kinetic energy? So it will be half mv square. So half mv square, when we substitute, the kinetic energy will also be conserved. So option D, the momentum before equals to momentum after, the kinetic energy before is equals to kinetic energy after. That's why for question 10, D is the right answer. Is it clear, this one? For option D to be a valid answer? So whenever a cushion is there, it's a perfect elastic, means the kinetic energy before should be equals to kinetic energy after. And the total momentum before must be equals to total momentum after. Question 12, 13, any doubt? Question 13, okay. Question 12. Which diagram shows the forces that provide a couple? What is the meaning of the term couple? It means like two forces acting in opposite direction and cause a turning effect in the same direction. That is the meaning of the couple. Like two forces acting in opposite direction, but cause a turning effect in the same direction. First, A cannot be an answer because the two forces are acting in same direction. D is also, it cannot be an answer, like because there will be a component will be there, component of the force, but not the two forces actually are opposite direction. There will be a component of this force, but not the two forces. Now we are left with C and D. Sorry, we are left with B and C. Now you can consider a pivot anywhere. It's up to you where you want to. Example, I consider this is a point of rotation. Why not D? Because the condition for the couple that the forces must act in opposite direction. The two forces must act in opposite direction. Here, the two forces, one of the forces acting vertically, another one is making certain angle. So they're not exactly in opposite direction. So when you check C, one is trying to cause a clockwise turning effect, another one is causing a same because the distance from the pivot is same. So the total clockwise and anti-clockwise turning effects will be same. So there will be no resulting turning effect. It will not turn at all. But what about D? Because the distance of this downward force is greater, so the anti-clockwise, the clockwise turning effect will be greater, and the anti-clockwise turning effect will be smaller. So as a result, what will happen? Overall, this will rotate clockwise. So this force having a greater distance from the pivot will cause a greater clockwise turning effect than anti-clockwise. So as a result, the object will rotate clockwise. And that is a definition of a couple, that two forces acting in opposite direction give rise to a turning effect in the same direction. We call moment due to a couple. Is it clear, this one? But how resultant is zero? How the resultant of the force is zero? If this force is 10 Newton upward, this force is 10 Newton downward. So whenever we work out the resultant of the force, we just check the direction, not their distance. So there's a force of 10 Newton upward and a force of 10 Newton downward. So what is the resultant force? The resultant force will be zero. But resulting turning effect will be there. If you consider a pivot at anywhere, there will be a resulting turning effect. Even I consider a pivot at this point. There will be a turning effect. One will cause clockwise. This is also causing a clockwise. So yes, any point I consider a pivot, I will always get a resulting turning effect. Is it clear now about the resultant force? In question 13, so we consider a uniform rod is there. So which direction this will cause a turning effect? Clockwise. This force is making certain angle. So we always take the perpendicular component. So this force will have the two component. One is with an angle. So the component which is with an angle, that will be F cosine 30. And the component opposite to the angle means the vertical component will be there. So that is equals to F sine 30. So F sine 30 is causing an anti-clockwise turning effect. Cosine 30 is not causing any turning effect because it is acting on the pivot. And the weight is causing a clockwise turning effect. And we consider the object is in equilibrium or balance. So the clockwise turning effect, which is 10 multiplied by distance from the pivot. They did not specify like a uniform rod is there. If it's a uniform rod, it means that the weight will act at the center. So if I consider the length of this rod as L, so what will be this distance? It will be L by 2. So 10 into L by 2 equals to F sine 30 into L. Because we always take a distance between the point of rotation and the force. So the force F sine theta is acting at a distance L and the weight is acting L by 2 because in the question, it's a uniform rod. So when we simplify this, L will cancel with L. 10 divided by 2 is 5. So F sine 30. If we need F, so 5 divided by sine 30. What's the answer? 5 divided by sine 30. So that is equals to 10. So C will be the right answer for this. So whenever you see a turning effect, so here is an object which is on the wall. A uniform rod is there, XY, with a weight of 10 Newton, and it's freely hinged to a wall at X. So means X is a point of rotation. Like around this point, it can rotate. So this is a pivot for us. A weight of a 10 Newton is acting downward. So which direction this weight will cause a rotation or try to cause a rotation? So this will try to cause a rotation in clockwise direction. So weight is acting downward, it will cause a clockwise. This force F is there, but this force will have the two component because the force and making angle 30. So we resolve the force into component. One is the horizontal, another one is the vertical. The vertical component